Welcome to the Smash News Network, least busted name in news. We're looking at GPS errors. We've seen a dip in the electron flux as forecasted with the arrival of a coronal hole wind stream. Also a small coronal mass ejection apparently struck. Make sure you watch our previous videos. This is 3 of 3 of our daily space weather video content. The total electron content is showing you the electrons in the plasma spheres and the inner Van Allen belt. The free electrons through which your GPS satellite must communicate. And of course, around the equator at noon, we see massive errors. Here's a diagram of what we're looking at here. What you're looking at is the electron count between your GPS satellite located at about 12,500 miles of altitude through plasma sphere outer, plasma sphere inner, and the inner Van Allen belt. Continuing on, we're going to look at the ionosphere in a minute. Charging hazards are non-existent at the moment. Here's the one-year chart of the electron flux. We're in more moderate levels here. And there you can see a cratering. Perhaps the arrival of the high-speed portion of the solar wind from the coronal hole wind stream, we can expect a big uptick in the solar wind speed. So there's the forecast model. You can see we forecasted a little bit lower levels here than NOAA did. And that is typical of coronal hole high-speed streams. A dip in the electron flux. The green boxes are the forecast. The yellow diamonds are not lucky charms. Those are the observation. So we're going to look at the ionosphere next. The F layer is located at about 300 kilometers of altitude. It's the bridge between Earth and space. And so while we do meteorology segments, this is a space weather video. This is your bonus features segment, folks. And thanks everybody for tuning in, by the way. If you're wondering if I think the ionosphere can be used to forecast earthquakes, the answer is absolutely not. Let's bring up the latest image and go to the anomalygram. So here's the anomalygram showing anomaly in megahertz from the 30-day median. The last was just the vibrational frequency itself. This is the anomaly from the 30-day median. Lots of high-frequency anomalies happening here around places like South America and the South Pacific, even the Central Atlantic and Central Africa seeing high-frequency anomalies here, and some big swings around the African Rift Zone here northwest of Madagascar. Here's the latest image from 1245 Universal Time Ionogram, 1245 Universal Time Anomalygram, and let's blast through some additional bonus features. First, I would like to invite everybody to join the Neo-Renaissance. Click the links below the video. Were you aware that we're in the process of writing a paper to explain the solar cycles? Yeah. The plausible mechanism underlying the solar sunspot and solar polar field reversal cycles. We're about to explain it. We expect to submit the paper for peer review by the spring equinox in March. So help us out by pressing like, subscribe, joining the Smash team, checking out the merch. You can find all kinds of links below the video, and so on. Here's a teaser. This is what merch we're offering. We've placed it all on the site throughout the month of February. If you see something you haven't seen before, pick it up during February. It may be gone come March 1st. Thanks to the Smash team members. Smashomash.com/Smash team is what we've replaced Patreon with. It's our own superior subscription services site. It's spectacular. Smash staff and I worked very hard to create this subscription services site, so please support the content via that. There is a gold and a silver and a gold annual paid-up subscription and even a free bronze level. There are even posts that you don't need to log in to see. You can see our daily video content posted there regularly. Next, some ground-based solar observatory imagery here from Cerro Tololo, Chile. And we've got a ton of filaments on the Earth-facing portion of the solar disk. Look at all the filaments. Filaments and filaments, even more filaments. How about some filaments here? There's some filaments there and some filaments there. So lots of filaments, folks. Likelihood of coronal mass ejections are quite high. Let's blast through even more data. How about the latest intensitygram and latest colorized magnetogram? Sunspot 2948, it still does have some trailing umbrae, making it still beta class. This group here, looking alpha class, this group here has grown since yesterday, so we've also got some additional umbrae up here. That could be a source of solar flaring. We'll be keeping an eye on it, and when I say ion, well, pardon the pun. So there are the fields with those regions. There's that alpha class sunspot group. There's sunspot 2948. You can see it still does indeed include some trailing North Pole ombre there. It's still beta gamma class, capable of producing flares. So don't be surprised to see some. Next, the current imagery here from the GOES 16 SUVI. You can see all those prominences there, mainly in the northern hemisphere. Lots of plasma hanging out. Will it eject? Will it collapse? Or will it remain stable? We want to know what you think. Let us know in the comments. We're going to close out with some additional imagery here in iron. Ionic iron spectra. This is 94 angstroms from the Solar Dynamics Observatory. Probably the best wavelength to view solar flares, if not 131 angstroms is, because of the temporal resolution. And we'll close out at the crowd favorite, or at least the house favorite, 171 angstroms. Another ionic species of iron. What's nice about 171 angstroms is it shows you activity before it's even visible from the earthly portion of the solar disk. It even shows you activity after it has set on the western limb. Anyway, thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.